Hello, this is my retrospective on my Graviflyer. You know, on the internet, I saw Alexi build one of these in Russia, and I decided that's what I want to do. I want to build one of these. I want to see if I can make it work. I want to see if his concept worked, and I wanted to see if I could do it. So, here's the result. I built my own type. I built two of them. One a little older, one newer, and I just wanted to share with you some of the insights that I found. I wanted to share with you things that went wrong, things that went right, and where we're going to go in the future with it. So anyway, I hope you enjoy, and here we go. So this is my first Graviflyer. I tried to model it just like Alexi's Graviflyer. I tried to cut different materials, build motors that you can see clearly so there's no shrouds or anything around them. And I got it up and spinning, and I put some voltage in it, and I used AC and DC. And I decided to go with DC, and the only reason I didn't continue with this model is it probably weighed 15 pounds. All threads on it were big, they're heavy. The plate was probably way too big in the center. I didn't care for all the heavy metal on it, so I went ahead and stripped it down and started over and built my own. Here's a look at Alexi's Graviflyer here. You can see the textured discs. I went ahead and found those at my local Lowe's. Also in these boxes you see the high voltage power source. It's a flyback transformer. Also you see a Tesla coil there. He put the wire in the center of the Tesla coil. For those of you who have never seen this, it just looks like sparks are attacking it when you put it down in that tube. And here you see him out in the field. He's got the thing up in the air. It looks nice. Here he is in the house with it lifting. That was a pretty cool moment right there. Made all of us want to build one of these things and see that it works. So this is the schematic that Alexi gave us. He basically told you that it runs on high voltage DC, that there's a Tesla coil attached to it, that he has a sound unit at the top from an ultrasound machine, and that each plate, one is positive on the top, the bottom one is negative, and that the center plate connects to the Tesla coil. He was kind of vague. There's a line that crosses between where the Tesla coil goes and to the negative of the plate. Usually it hops over, but in this case it just crossed it, which is confusing. He also put in a bunch of diodes at the top, making it confusing as well. Didn't need to add all those. The flyback transformer has that in them, so you don't have to add that there. As long as you just specify which transformer you're using. Made a lot of confusion for a lot of people on this. Also, a lot of people tried to up the voltage on this, and I'm one of them. I won't deny that. But it made for some confusing times on this, with him only being, maybe an inch off the plate, the center plate there. There's no way he got past the flyback transformer and maybe 18 volts at 3 amps, running that without it sparking out. You know, I thought for sure that this thing was just going to lift right off the table. It was shaking all over the place. It was, it looked like it was light as can be. The truth is it weighs 3 pounds, the whole unit, so it wasn't very heavy. But it looked just like, it had massive lift to it. I hooked one flyback transformer up with a ZVS driver. It runs about 380 watts, 19 volts, 2 amps put into it, maybe 3.5 at the most. But I thought for sure it was going to lift. It sparked a lot on the high voltage on the disc. There was not a lot of ion smell in the air. So it was a clue that I had something amiss, but I gave it a run, and it looked like it was promising, so I went ahead and continued from there. At this point right here, after seeing it run initially, I thought, well, let's play with the speed a little bit. Let's speed up the upper disc, then slow it down. Let's do the same to the bottom. Let's run it evenly at the same RPM, and let's see what runs the best. Truthfully, the top always ran a little faster than the bottom. The bottom itself had to have more torque to drive it. So it took a little more on the controls actually, but it was probably right under the speed. So we're about 2,800 RPM usually on the top to get a consistent flow, about 2,700 on the bottom. Would like to bring it up more, but it just brings the whole thing out of whack and out of balance. 25 was really good too. So I guess in the end you couldn't get it to oscillate between the two, but if you get them close enough, that's why I ran it at like 26 on the bottom and then turn the top to 27. At that, it's still balanced okay, but you got a lot more in the same range of frequency between the two discs. So this is just a speed test to see what's going on and see how unbalanced it was, and I finally got it in tune. So most people seeing this for the first time thought probably, you know, is it going to lift? It looks like it's shaking around. It looks like it might go somewhere. Or some of you just thought flat out, this is just something shaking around on the table. And to be honest with you, it turned out to just be something shaking around on the table. I'll play it here for you. You know, sometimes it looks like it's lift. Sometimes it looks like it's so light it can come off table. Well, it weighs 3 pounds. Of course it's going to look like it's going to come off table. What's the problem? Even with all the high voltage I put in this, there is no lift factor. It just isn't there. So here I am, I fogged up my garage. Basically, I just wanted to see if the discs had any air movement around them, if there was any kind of lift from the air movement at all. I found out there wasn't a whole lot of air movement at all. I mean, we got maybe a tiny breeze there from each disc, but there was nothing until you turned the high voltage on that you would get any kind of breeze from this thing. I checked it with other testing that I did, and it came out pretty much the same way. So if you were standing next to this thing in the middle of the night and it was just hanging out next to you, you wouldn't even know it's there. But yeah, in this test, it was pretty much we wanted to see if there's any aerodynamic features to it, any way to improve it. Maybe a shroud underneath the bottom one might have got something to flow a certain way. But ultimately, this was just a failed test of any kind of wind flow on it. Even with the high voltage on, it wasn't that great. At this point, I haven't perfected my disc plate adjustments to get them right where they need to be for all the ions. But yeah, it was a pretty good test. It tells you a lot about something when you put it in fog and you blow it on it continuously, or just have it in the air. You can kind of find out if there's anything going on with it. It was a very useful test. So at this point of the build, I thought I really had it. I thought I was well on track to get this done. I had finally gotten the ions to produce at night. You can see it, the nice aurora that it makes right there. Nice glow, okay? I thought I was finally going to get there and get this thing lifted. Well, it didn't quite turn out that way, but it made a really nice show. This test right here was one of the most informative tests I've ever did to this whole Graviflyer. Basically, once you set these plates and you get this thing running, you don't see this a whole lot during the day. You have to wait until nighttime to see it. It has to be perfectly dark outside, a little bit of backlight maybe from your garage or something. But this right here, this aurora that it puts off is awesome. The only problem is to get it to go that thick, like it was in some of these video pictures you could see. You had to put the plate closer to the center than you wanted to. I put negative on the center plate, positive on the little plate there, and you got this nice aurora. You got it to go really heavy on there, but in order to stop the constant sparking across the disc there, I had to raise it up a bit, and it just took away a lot from the ion flow. The problem is every time it sparks, you get the ion flow to stop. Every time that it's roaring like this with the aurora, you're good to go, and you get a ton. I mean a ton. You better have it well ventilated, because you're getting a lot of ions off of this, way more than it would be if you did like a wire to wire or just a simple lifter. You get a lot. This is like 2 to 3 times that amount because of the spinning disc. It makes a huge difference in how much of the ion flow you actually get. this was one of my funnest tests because I got to see something positive from this. Besides it just shaking around, I got to see this thing really give off some stuff and show that it has something good to it. So I really like this one. So let me just share what's going on right here. I took off the bottom half of my Graviflyer. I just wanted to know if it would run without the bottom part with the magnets on it and stuff like that, and if I get any different result. As you can see here, it's just sitting on the board, and I'll let you watch it for a minute. What you're not seeing on this video right here is it's digging into the wood. Each one of the corners here on these cut in about 1/4 inch into the wood. Every time that the smaller plate goes to the bigger plate in the voltage, there's a shift. It's pushing it down. So if I flip this thing upside down, it'd be pushing it up. What's the problem? There's not enough of it. It's just not enough there. I can't put enough voltage in it. Every time I put more voltage in it, I have to increase the gap between this plate and this plate, and it keeps getting bigger and bigger. Now, could it possibly work with a lot more voltage? Well, probably more voltage than I want to play with at this time. I have put a lot into it. Okay, we're talking a 3 to 4 inch spark gap. Anything more than that, you get into lethal conditions, and let's face it, in somebody's garage, it's not a very good thing. So, as you can see, the voltage right here, the ions, you can barely make out a feel around it sometimes, but it just dug. It dug right into the wood. Okay? So, some of these tests I do, when I share them, it's just raw footage. So I just wanted to give you some insight into that. It was digging in. Is there something that could be perceived as lift later on? Well, the answer is yes, and the answer is no. I haven't gotten there yet, so it'd be no. The answer is yes, that it shows signs if the voltage is high enough. Okay? Problem is, I don't have a facility to put this in and put enough voltage in it to make the difference it needs to. Now, it probably took, what was this, probably about a minute to dig about 1/4 inch into the wood. So there are signs, okay? So it's not hopeless, it's just not something that I'm able to achieve at this time. At this point here, I had done everything that I could do to this Graviflyer to make it fly. I looked through every tape Alexi put out. I looked through everything that I could find, every bit of information. I talked to people. I asked them what they thought that they could do to make it lift, and everybody had a different opinion. Some thought it was just in the resonance. Some people thought it was in vibration. Some people thought it was in the air temperature outside. And, you know, there's just various things that you could do to this, and trust me, I tried all of them. So at this point, I just decided voltage is the answer. Let's just slam this thing with some more voltage. So I put 2 flyback transformers together, run them on a ZVS driver, and it's about 320 watts for the ZVS driver. And then I went ahead and added frequency to it. So if the top plate and bottom plate are within the same frequency range, why not add frequency to it? See if we can't boost that up just a little bit and keep it in the same range. So the frequency is cool. It actually shows you, you know, what sounds it makes at high frequency and stuff like that, which ones are in your range and out of your range of hearing, which is me for a lot because I can't hear much. But anyway, I built Tesla coils for this thing, several of them. I probably built 6 Tesla coils for this thing, various size. Here's an example of a couple. I went ahead and built a bifilar coil for the bottom of this thing. I velcroed it to the bottom and tried to use it. Anything to push those magnets down to get some kind of lift in there. The problem is, and anybody will find this out, when you start rotating something, to get force against the rotation, to get anything to hit that, it's very hard. It won't force those magnets down. It may create a sound, but it will not force the magnets down. And that was kind of a downfall. So you'd have to run the bottom plate at a very, very low speed in order to see anything. I thought it was going to be real good. To be honest with you, this thing from the beginning probably should have had a Tesla coil right in the center with the bifilar coil in the center of that as a pulse coil, maybe a half the size, would probably have done this thing a lot of good. The rotation should have been separated a little bit, but there's a lot of different things you could do to this. Those are some of the examples I would do when rebuilding it again. But yeah, I basically threw the kitchen sink at this thing, and this is where we are. So let's answer the final question here. Did this thing ultimately work in the end? And, well, the answer is no, because you'd be seeing it flying right in front of my face right now. But did it give us great insight on how to build more UFO type crafts? Absolutely. It showed us different things on how things can dig into the wood or lift just a little bit off the ground with a little bit of voltage. What's the problem? We don't have enough voltage to put into it. Okay? I don't have enough in what I have today to do it. May it work in the future? I can tell you this, if I get a higher power source, I'm sure zapping this bad boy with it. Okay? I'll make all the adjustments for the distance and everything, and we'll see if it works. Okay? At this point, with this distance, I'm going to say it doesn't work. Between the plates and the center plate, there's not enough energy there to make it lift. Is there enough to force it down into the ground? Yes, there is. Is there enough to lift it off the ground? No, there's not. So would I build it again? Yeah, I think I would, to be honest with you, because it taught me so much more. You got to work with high voltage, you got to see plasma arrays, you got to see all kinds of insight into where we need to go with it. I honestly think if you took this thing and put a propeller under it, and that sounds bad, but you got it up into the atmosphere, it would have a total different reaction. You got to remember, we're on the surface of the planet. We're being pulled down. Up there, you're being pulled up. It's a whole different world. So I think maybe some testing needs to be done of, and I know it sounds sacrilegious, but maybe you got to put a propeller under it and get this thing high enough where you can find something out. We know a Corona motor works up that high. Let's try one of these. Maybe we'll have a different result. I'm building another one. Matter of fact, I'm building other ones now. Okay? I'm moving distances. I'm getting more voltage. And you know, one of these days, one of these things is going to work. Unfortunately, it wasn't the day for this one. This one didn't pan out. It didn't work. Great things about it. Learned a lot. But it's just not there. Not yet. And as far as what Alexi did, you make up your own mind on what he did. I'm just telling you what mine did, and this is where I'm at today. Thank you guys for watching. Make sure to like and subscribe. Thank you. Bye.